Hello friends, today we will study ERTMS, the European Rail Traffic Management System. This was developed to solve one of the biggest problems in European railways, different signaling systems in different countries. By the end of this lecture, you will understand why ERTMS was needed, how it was developed, and what benefits it provides, especially for high-speed rails. Traditionally, each European country developed its own railway signaling and train protection system. These systems were designed independently without coordination at the European level. As a result, today we have many different ATP systems operating across Europe, making railway operations complex and inefficient. Existing train control systems. Most traditional systems work by transmitting information from track to train at fixed points using beacons. The train receives information only when it passes these points. Between them, supervision is either intermittent or semi-continuous, which is not sufficient for modern railway requirements such as high speed and high traffic density. ATP distribution in Europe. This figure shows the distribution of different ATP systems across Europe. You can see that each country uses its own national system. This lack of standardization creates serious challenges, especially for international train operations. Interoperability problem. Because national systems are not interoperable, a train crossing borders must either be equipped with multiple onboard signaling systems or change locomotives at the border. In addition, driver must be trained to operate several signaling systems. This increases cost, complexity and delays, especially in cross-border rail transport. Current demands on rail transport. Modern rail transport must compete with road and air transport. To do this, railway must offer high speed, high capacity, high reliability and high safety. Traditional signaling systems are not capable of meeting all these demands. Safety limitations of existing systems. In most older systems, the driver carries almost all responsibility for safety. Train supervision, if available, is limited and not continuous. This makes these systems unsuitable for modern high-speed operations, where automatic and continuous protection is essential. Capacity and speed challenges. Capacity and speed challenges. National signaling systems were not designed for very high speeds and dense train traffic. As traffic demand increases, these systems become a limiting factor. They cannot support the level of performance required on modern and high-speed railways. Economic challenges. Railways must reduce costs and improve efficiency. With increasing privatization, railway companies must remain competitive. Maintaining multiple signaling systems leads to higher installation costs, higher maintenance costs, and higher training costs. A unified system is economically necessary. Need for a common system. Due to all these problems, a single interoperable signaling system became essential. Such a system would allow seamless cross-border operation, eliminates border stops, and reduces technical and operational complexity. This need lead to a development of ERTMS. Introduction to ERTMS. ERTMS stands for European Rail Traffic Management System. It was developed at the European level to create a common signaling and train control system. While interoperability is its main objective, ERTMS was also designed to be one of the most advanced train control systems in the world. Objectives of ERTMS. The main objectives of ERTMS are full interoperability across Europe, improved safety through continuous supervision, support for high speed and high density traffic, and reduction in overall system costs. ERTMS is not just a replacement, but a complete modernization. Benefits of ERTMS. ERTMS offers many technical advantages. Increased capacity, up to 40% more trains on existing lines. Higher speed capability, up to 500 km per hour. High reliability, improved punctuality. These benefits make rail transport more attractive. Additional advantages. With ERTMS Level 2, ground signals are no longer required, which reduces maintenance costs and improves system availability. ERTMS also creates an open supply market, allowing multiple manufacturers to compete, reduce costs, and increasing innovation. Continuous supervision significantly improves passenger safety. Development of ERTMS. The first focus of ERTMS development was ETCS, European Train Control System. ETCS was formed as a subset of ERTMS and included Eurobalas, Eurocab, and Euroradio. These components form the core of train control. GSM-R system. Along with ETCS, GSM-R was developed. It is based on GSM technology and provides voice communication and data communication. GSM-R acts as the communication backbone of the ERTMS system. ETCS development process. ETCS was developed by a consortium of experienced companies. Each company contributed knowledge from its national ATP system. The goal was to combine this experience into a single interoperable European system. ERTMS bar ETCS characteristics. ERTMS bar ETCS is an automatic train protection system. It consists of onboard subsystem called Eurocab and trackside subsystem called Eurobalays. All components use standard interfaces and protocols. Communication methods. Communication between track and train is achieved using beacons, loops, and radio communication via GSM-R. This enables continuous supervision, which is essential for high speed and high capacity operations. To conclude, Europe needed a common signaling system. National systems could not meet modern requirements. ERTMS provides interoperability, safety, capacity, and speed. ERTMS represents the future railway signaling and control systems in Europe. Okay, thank you.